Hey friends, it's Rain. Another week done, let's go. I think this should be like week 6 or week 7. I lost track of time. Anyway, there wasn't really much in lab, we just distilled the rest of last week's experiment and then redid the whole experiment, this time with an overhead stirrer, because the just stirring capability of an overhead stirrer is a lot more and can finally stir that pudding, and it did. It's basically just stirrer that sits on top of the flask and then goes in the flask and has an external motor rotating it, so more power. And it kind of worked. And then, Thursday we spent the rest of the day just distilling it, which took almost 2 hours, even though we used only a small Vigreux column. But yeah, so that's basically it. There wasn't really anything else. In green chemistry, I have an assignment coming up next week, which I'm gonna do, kind of excited about. And apart from that, organics exam is coming up, and a bit scared. I hope I can do it. I'm sure I can do it. I should just sit down and study all the different mechanisms and stuff. But yeah, that's coming up in like 3 weeks, 2.5 weeks, not entirely sure. So anyway, since I didn't have much to do, I thought I would just explain real short how distillation itself works and what this Vigreux column we're using even is. So distillation itself is actually rather neat and rather simple. You have a mixture of two liquids and they have different boiling points. For example, the thing we're making has a boiling point of around 66-ish degrees Celsius, and the toluene we used has a boiling point of, 120 or so. So if we just heat up our apparatus, our flask, with both liquids mixed to, let's say, 70 degrees, all of our first solution, all of the first liquid, should just start boiling and evaporate and go over into our distillation apparatus, which is cooled, where then it would sublimate and drop into another flask. And the toluene, which has a boiling point of 120, would still stay liquid at 70 degrees Celsius. That is how distillation works. So normally you would just take your distillation bridge, the one that has water running through it, cooling everything, so your vapor could turn back into a liquid. And you would just stick that on top of your flask, and that's it. But sometimes you want maybe the boiling points of your two liquids are really close together, and it's kind of hard to just make like a distillation work perfectly. You would always end up with some of the other product over there, because that's how clouds work. It's just vapor, different vapor and different chemicals. So some of your product that you want could trap some of the toluene, for example, and carry it over into your product flask, which you don't want, because you want this to be like clean and only have your product. And this is where distillation columns come in. And I have here like a rough sketch of a Vigreux distillation column. This is just a picture from Wikipedia. And as you can see, it has these little spine thingies all around on both sides, and like these are on the front and back. And what those spines do effectively is give the vapor more area where it can condense and turn back into a liquid, drop back down, get back heated up again, rise, so on and so forth. So the entire mixture basically just sits there for a long while, and this improves the capability of dividing the two liquids from each other, since the one with the higher boiling point, which gets carried up, will also condense again and drop back down, and the other one will slowly rise up through the entire column into your bridge and then finally land in the product flask. That's how it works. And there's different columns, all have like different ways of how they work. There's even some columns which are hollow inside completely, and you just fill them with, like, for example, little plastic thingies that give more area, and so on and so forth. So you basically just increase the area in which your gas can condense and turn into a liquid in it. But the problem with those columns is, of course, it takes a lot longer to distill something, which is why we spent like a good 2 hours in lab just standing there looking at it. So yeah, that covers the Vigreux column and distillation columns and distillation in general. I hope I explained it well enough and you have an idea how it works. And yeah, I just want to say thank you for all the love and support my last video got. It is so far the most popular video, and I read all your comments and I love you guys. It is so cool. Your love for chemistry it makes me very excited, and I'm very excited to record new videos. So yeah, that's pretty much it. I hope you're having a wonderful week, and I'll see you guys next time. Bye!